Okay, I hope everyone is doing well, at least. After the disaster that happened, I think most of you are still working on your, electricity problems, water problems, and everything. But definitely we have to carry on. And so there is no pressure that if you don't do things on time for time being. So therefore you can take this a little bit casually if you want, but don't take it too casually. So we start off with our fifth class on the chapter continuity and differentiability, and today we are going to deal with the logarithmic differentiation, another aspect of differentiation or derivatives, and it's a very useful tool which you may require in your future for doing some difficult complex differentiations. Now let us just understand when we require to use logarithmic differentiation. So obviously we have completed the first four topics, and today we are going to deal with the fifth one. So now in the introduction, so now when do we require to use logarithmic differentiation? When we have a situation where a function is in the exponent of a function. Function is in the exponent of a function means when I have, say for example, x to the power x, or x to the power sine x, or log x to the power x, something like that, where one function is in the exponent of another function. So pretty much if I generalize, then it looks something like this. So fx to the power gx, or fx to the power gy, or gy to the power gx, or gy to the power fy means any function to the power another function. If such is the case, we generally make use of logarithmic differentiation. How we do it, we are going to deal with it in the problems. And also, it's not just only in this kind of situation. You can also make use of logarithmic differentiation if you have a UV form. UV form means if there are two functions multiplied, two or more functions multiplied or divided. Why? Because if the functions are multiplied or divided, by applying log on both sides, you can turn those multiplications and divisions into addition and subtraction, because we know log of mn is equals to log m plus log n, and also at the same point of time log of m by n, that is equals to log m minus log n. We already know that doing differentiation for uv and u by v form can be a little bit cumbersome because you have to do a lot of calculation. But once we can split it into additions or subtraction, then it becomes very easy for us to do the differentiation. So that's generally the idea where we can make use of logarithmic differentiation. So let us take problems and understand how it works. Now, before we go into the problem, let me just give you a quick heads up. That is, in this particular topic, the answers or to the problems will be a little bit big enough to cover up your page. So don't be scared at the beginning. If you have a book, please go through your examples, and also I will have some solved examples here, so you'll get fairly some good idea about how to deal with this kind of differentiation. So let us move into our first problem. Now, first problem is find dy dx if y is equals to under root. It's a very complex expression, you can see. Now, if I try to deal with this in a normal differentiation, you can understand that there is a square root, then there is a division, and also in the numerator and denominator of the division there are so many expressions. So trying to do a normal differentiation on this can be a little bit troubling. So what we do instead, we apply log on both sides. So if I apply log on both sides, this exactly what happens. Log of y becomes log of this expression. Now we need to remember certain properties. I am just writing it once again. The first property is log of m to the power n, that becomes n log m. This is one property. This is the first property we need to keep in our mind. The next property is log of mn, that is equals to log of m plus log of n. And of course, the third property is log of m by n, that is equals to that is log of m minus log of n. So pretty much these three properties we need to keep in our mind. We will be making use of these three properties frequently in this kind of differentiation. So once we have remembered these properties, so let us see what happens. So now root over, there is a root over outside, so that means it is to the power half. So half comes out first. So this is exactly what happens if I apply the properties. So it becomes half of log of x plus 1, x minus 1 plus log of x minus 2, and then x minus 3, x minus 4 and x minus 5, they are in the denominator, so they become negative. So you can see the complex expression that we had, it becomes simplified, because now each and every single expression is standalone expression. So once they become standalone expressions, it becomes very easy for us to work with. Next, now let us do the normal differentiation. So log y, when I differentiate, log y, the differentiation is 1 by y. But as we are doing the differentiation with respect to x, y needs to be differentiated, that's the chain rule. So it becomes 1 by y into dy dx. And then on the right side, rest of the differentiation is exactly how it is log of x minus 1. If you do the differentiation, it becomes 1 by x minus 1, 1 by x minus 2, 1 by x minus 3 and so on. So now what we are left to do, we are left to side transpose the y on the other side, so it becomes y by 2. But exactly our answer should contain only x, means in most of the cases our answer should contain only x. So what is y? Y is the expression which is given. So let us put back this expression in place of y. So if we put the expression, and that is our answer. So I told you already that your answer will be a little bit big enough. It will be a very complex kind of an answer, but definitely have faith that this is your answer. So you don't have to do any simplification hereafter. You can leave your answer just at this stage. Fine. Next, problem number 2. If y is equals to cos x, cos 2x and cos 3x, then you have to find dy dx, obviously. So now before I go on applying log on both sides, you can see you can directly do the differentiation using UV method. Now no problem with that, but let us try doing it using logarithm and let's see how it helps us. So if I apply log, then what happens? Log of y is equals to log of cos x plus log of cos 2x plus log of cos 3x. That is the multiplication property of log. Now let us do the differentiation. So log y when differentiated, it becomes 1 by y dy dx, and log of cos x when differentiated, it gives me minus tan x. Now how that comes, if you just break it down, let me just show you one breaking, then you can understand. Log of cos x, when you do the derivative, log of something, when you do the derivative, it becomes 1 by something. So it is 1 by cos x, right? But cos x is a function in itself. So by chain rule, I have to differentiate cos x. So differentiation of cos x is minus sin x. So that gives me in turn minus tan x. Fine. So that's exactly how it comes. Oh, I think I made one small mistake. I have forgotten to add 2 here. So please don't mind. There will be a 2 here. There will be a 2 and there will be a 3. Minus 3 tan x and minus 3 tan 3x and minus 2 tan 2x, which I missed. So please ensure you put it. I just missed while typing it. Next, Now if I just put it here, obviously there will be 2 tan 2x and 2 tan 3x. Please ensure you just do it. This is 2, this is 3, there is 1 2, there is 1 3. So which I have missed in all the steps. Please ensure you put it. Next, so this is exactly your answer, but obviously with that small mistake. So ensure there is 1 2, there is 1 3. So this is your answer basically. Fine. So I hope the idea is pretty clear. Now if you would have done it using your normal derivative method, I am pretty sure you can understand that you would have had to do 2-3 steps a little bit more maybe to arrive at this answer exactly. Okay, so now let us move to the next problem. Problem number 3. Problem number 3, if y is equals to x to the power y, then prove that x dy dx is equals to y square by 1 minus y log x. Fine. So you are already given an expression to prove, so we have to ensure that we arrive at exactly this answer. So first we do what? We apply log on both sides, so it becomes log y is equals to y log x. Then let us start with the normal derivative. So if I do the normal derivative, see on the left hand side it is 1 by y dy dx every time, so no problem with that. Now y log x, it is in uv form, so first I keep y fixed and do the derivative of log x. It is y by x plus, now let me keep log x fixed and do the derivative of y, so it becomes log x into dy dx. Fine. Now let us collect the terms of dy dx on one side. If I do so, then it becomes 1 by y minus log x into dy dx, and on the right hand side I will be left with y by x. On doing some LCM and calculation, so you can see this is what it comes. Now I have to do some side transposing. Now y goes on the other side, it becomes y square. 1 minus y log x comes to this side, it goes to the denominator, and x goes up one on the other side. So doing all these changes, I arrive at my answer. Sorry. So this is pretty much how simple it is. It's just that you have to ensure after applying log on both sides, you have to do the derivative a little bit carefully, because in different problems the derivative can become a little bit longer. Let's move to the next one, problem number 4. Now in this problem number 4, we have to understand that there are two things to work with. So it is given y is equals to sine x to the power cos x plus x to the power sine x. I need to find dy dx. So when I am doing so, you see I can't apply log to the whole thing directly. Why? Because there is one plus in between, and we know log of m plus n doesn't give me any property. So there is no property of addition inside logarithm. Multiplication inside logarithm becomes addition outside, but definitely not the other way, or we don't have any as such specific property where the addition inside logarithm turns into something. So therefore what we do instead, we consider the individual terms separately, one as u, the other as v. So now what we will do, we will address these two functions separately. So let us start with u. So what is u? U is given sin x to the power cos x. So now if it is sin x to the power cos x, now let us apply log on both sides. So it becomes log u equals to cos x log of sin x. Let us do the derivative. So it becomes 1 by u du dx equals to, now obviously there are two functions here. If you can understand here, I have two functions. One is cos x, the other one is log of sin x. So I have to apply the multiplication rule. So let me keep cos x fixed and do the derivative of log of sin x. Once again, if you do the derivative of log of sin x, you will see it becomes cot x. And next is we keep log of sin x fixed and then do the derivative of cos x, which is minus sin x. Fine. And then send u on the other side. U is nothing but sin x to the power cos x. So this is my one part of the answer. Next, let us work with v. What is v? V is x to the power sin x. So again, let us apply log. So log v is equals to sin x log x. Then if I do the derivative, just go through the derivative. I think I need not explain it anymore. Then following the steps, I have dv dx, that is equals to x to the power sine x into the expression inside the bracket. Now, what did I start with? I started with y equals to u plus v. I considered y to be u plus v. But what I need to find out, dy dx. So what is dy dx? Dy dx is actually du dx plus dv dx, and exactly those two expressions I have already found out. So what I need to do, I need to just write those expressions and put an addition sign in between. So basically this is your answer. So you can see how big the answer looks like, but actually if you take it part by part, then definitely they are not that complex. I hope this is clear. Then let us move to problem number 5, the last one. Find dy dx if sin x to the power y is equals to x plus y. So once again, now here in this case, as x plus y is a small term, I can think of putting log on both sides. So I will be doing exactly that. So if I put log on both sides, it becomes y log of sin x is equals to log of x plus y. Now let us do the derivative as we have been doing. So again, y log of sin x derivative is cot x, and then if you fix log of sin x, derivative of y is dy dx. And log of x plus y derivative, log of something, its derivative is 1 by something. So log of x plus y derivative is 1 by x plus y. And again, if you do the derivative of x plus y, it is 1 plus dy dx. Now again, what do I need to do? I need to collect the terms of dy dx on one side and rest on the other side. So if I do so, what do I get? I get this. Once again, I have done another small mistake while typing. This plus should not be plus, this should be minus. Please bear with me on this. I have been a little bit casual doing it myself, so there are certain mistakes. Now next, I need to just do the side transpose. Once I do the side transpose, again once again this is minus, this is not plus, this is minus. And once I do this, then do the side transpose. So this is my answer, obviously with this sign to be minus. Fine. So basically this is your logarithmic differentiation. Nothing pretty difficult about it. It's just that the calculation becomes a little bit lengthy, or the expressions become a little bit lengthy, but still if you do it a little bit carefully, I am pretty sure you won't be having much trouble understanding. So do go through the problems, also go through the problems given in your book, and then definitely try solving the exercise. Thank you. Let us meet in the next class.